So now we're going to start graphing the tricky stuff, the phase shifts or the horizontal shifts. Okay, so now we have the graph y equals sine of x minus 2. So what we know about this graph is that it's going to be the graph of sine x shifted 2 units to the right. Okay, so that should make sense. When we take our points, we're going to be moving each point approximately 2 units. But we have to be careful because when we actually take a look at this, 2 units is not going to be as simple as the vertical changes. Okay, so now how do we start every graph of this nature? Well, we start with our amplitude, which is equal to 1, right, because that's the number in front, and our period, which is equal to 2 pi divided by the frequency, which in this case is 1. So it will be 2 pi. Okay. Now, what are we going to label our axis with? Well, we know that all the major features of my graph are going to be at the places where my period is divided by 4. So that is pi over 2. So at every pi over 2 units, we should have a min, a max, or a 0. Okay, now when I choose my axis labels, before I had made everything 4 boxes. And that's because I didn't really care what those 4 boxes were equal to. But now I have to keep close track of what each individual box on my x-axis is equal to. All right, so to make my life easy, I'm going to label this, right, every 2 boxes, pi over 2. And that's because I know that if I had to divide it by 2, I would get that each box is actually equal to pi over 4. Now, we don't necessarily need that right now when we do our sketch, but it's going to be important when we do our shifts. Okay, so every 2 boxes is going to be equal to pi over 2. So this is going to be pi, 3 pi over 2, and 2 pi. Now, again, I'm graphing from 0 to 2 pi. So whether or not my... Whether or not my period was equal to 2 pi, I would still need to continue the graph all the way to 2 pi. Okay. So we have our amplitude, we have our period, we have our major places where our points are going to be. So the first thing I'm going to do is I'm going to start with the sketch of the parent function. So the sketch of sine of x. What happens before we shift it? Now remember, sine starts at 0, moves up to my max, which I'm going to say 1, 2, negative 1, negative 2. Goes back down to 0, down to my minimum, back to 0, giving me the curve that looks like this. Now I'm drawing it with a dashed line because that's not the actual picture we want. So now what we want to do is we need to shift everything to the right 2 units. Okay, which means some of the graph on this side of my y-axis is going to follow us onto when we shift. So let's continue this graph just a little bit. So at 2 boxes, it should be down to my minimum, right, to continue, and then another 2 boxes back up. Okay, so we want to keep that there because we know we're going to be shifting to the right. So now the next question is, where exactly is 2 units? Is it 2 boxes? No, it's not. Because 2 boxes is equal to pi over 2, which if you type into your calculator, okay, is equal to 1.57. So 2 boxes is going to be shy of 2 units, which means the shifts that I'm going to make are going to be 2 boxes and a little bit. Okay, so when I go to shift these, and I'm going to do it with a different color, I'm going to shift it 2 boxes and a little bit because that's going to be bringing us to the 2 full units to the right. All right, 2 boxes and a little bit, 2 boxes and a little bit, 2 boxes and a little bit, 2 boxes, oops, and a little bit, 2 boxes and a little bit. Okay, so I have shifted all of my points. So now I'm going to connect them. So we have from here to here. Keep going. Okay, so now let's see if we've followed the instructions. Have we graphed on the interval from 0 to 2 pi? Well, 2 pi ends here, right? So actually, I can erase everything on my graph past that value. So that I don't need. Okay, even though it's still part of it, it's not what we need for this question. Similarly, we need to make sure we start at 0. So since I'm at my minimum, remember, it's going to be going up just a little bit. So that's going to have a slight curve to it. Okay? And everything else is good. Okay? So that's my graph. Now, you may want to spend some time clearing away what's not necessary, right? We don't need all of these shifts. And technically, we don't even need the original parent function, right? So this is how we could get a nice clear picture, okay? So now let's say you were unsure if this was correct. How can we check this work? Well, one thing that we can do is we can use our graphing calculator, okay? So you can type in the equation into the y equals section of your calculator, and it will plot the points for you. Okay, so you want to type in sine of x minus 2. And when you press the graph button, you'll see an approximate graph, but you'll see a lot of bounces. And that's because the screen is not necessarily tailored to what you're supposed to be putting on your paper. So there are 2 ways to adjust the screen. First, you can press zoom, right? And at option number 7 is something called Z-trig. Okay, so what this will do is it will allow you to have a graph that is more appropriate, that has a more appropriate scale for trig. In fact, the values along the x-axis would be in terms of pi on this particular graph. The other option you have is going to window. Okay, so now what do I need to do for my window? Well, if I'm graphing from 0 to 2 pi, I can make my x min minus 8.63 and x max equal to 8.6. Oh, that's what you should see. I could change it to 0 and 2 pi, right? So instead of having all that extra space, I can really narrow down my search. Now, if you continue further, the x scale, if you look at what you have there, is 1.570. That means the scale that they've chosen is pi over 2. So when you go to look at your picture, every line you see on your axis is actually these values that we plotted right here. Okay, so now how else can we use this? Well, if you press second table, right, it will give you the table of values. However, you need to be careful because remember, on this graph, 1 box does not mean 1 unit. Okay, so if you wanted to know, on the table, we have the point 0, comma, negative 0.909. Well, that's something we had to graph. And yeah, it's approximately at the negative 0.909. But when we get to 1, comma, negative 0.84, remember, each box is equal to pi over 4. Pi over 4 is equal to 0.785. So 1 unit is going to be approximately a little bit past 1 box. And yes, that's at approximately negative 0.804. 2 is at 0, which we understood because we actually shifted it that direction. And you can keep going and work your way to see approximate points. Remember, 2 pi is equal to 2 times 3.14. So my graph here is going to end at 6.28 approximately. Okay, so you're not going to need to look past those points. So that's one way to check the graph. So let's try another. Graph cosine of x plus 1 plus 3. Well, first let's talk about what changes are happening. Well, this is taking my cosine graph and shifting it up 3 units and shifting it to the left 1 unit, right? Because plus, will bring me to my left. Okay, so now what do I have to do? Well, I start in the same place that I would for every single other graph. And that is with my amplitude, which in this case is 1, and my period, which in this case is 2 pi divided by 1, which is 2 pi. Okay. Now I need to find what I'm labeling my x-axis with. So I take my 2 pi, I divide it by 4. So I'm actually going to label this graph in the same way that I did in the last question. Okay, I am going to label it, every second box is pi over 2. So I'll do that, 3 pi over 2 and 2 pi. Remembering that each box is equal to half of that, which is pi over 4, which is approximately 0.78. Okay, so what's happening? Well, we're going to start with our parent function, and we're going to shift it. Okay, so my parent function is cosine graph. And we're going to make each one equal to 1. Okay, so we know that if we were to graph cosine, it would start at my maximum value. So that's what I'm going to do here as well. For my parent function, I'm going to start my maximum value. But remember, maximum value is my midline plus my amplitude. So my midline is at 3. So my amplitude is 1. So the maximum value that I'm starting with is 4. Okay. Now at every pi over 2, I'm going to hit another major feature. So pi over 2 is going to be 0, which in this case will be my midline. Pi is going to be my midline minus 1, 0, and then here. Oops, sorry. Now, because we're going to be shifting left, I'm going to continue graphing this. So in another 2 units, I should be back at 0 again. In another 2 units, I'll be back at 1. Okay? And the reason I'm doing that is because that way I can shift all of my points the appropriate direction. Okay? So we've taken care of my vertical shift by starting at my midline. So now all that's left is for me to take this left 1 unit and shift all my points. So 1 unit is going to be a little bit bigger than 0.78. So that means I'm going to be shifting 1 box and a little bit, right? So if I was going to shift this to the left 1 box and a little bit, it should be approximately right there. This 1 box and a little bit, which is right there. 1 box and a little bit. 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 Should connect it. Okay, so now when I connect these points, right, this should be something like this. Okay, so now what can I erase? What can I get rid of? Well, I'm stopping at 2 pi, so I can actually erase everything past it. Okay, that was all just to help me. I'm starting at 0, so I can actually erase all of this as well. And I'm going to start erasing where my cosine function was. Okay? And that is my graph from 0 to 2 pi. Again, you could check these values using your calculator and looking to see the table. Okay, but the key to these graphs is going to be matching the shifts with the axis. Where is 1 unit on my scale that I have chosen? Okay, so now anybody in my honors class, proceed forward to the next example. Or if you're ready to challenge yourself, you can proceed forward to the next example as well. Okay, so now we're going to link everything together and graph y equals 3 sine of 2, parentheses, x minus pi over 3 minus 3 over 2. So we have this example actually in yesterday's notes. In yesterday's notes, we identified all the changes from the equation, right? So now what we're going to do is we're going to graph it. So what do I need here? Same thing as I always need. I need my amplitude, which in this case is the number in front, 3. I need my period, which is 2 pi divided by my frequency. Now my frequency is the number in front of x factored, which this is factored, so we can go directly into it, making my period pi. I need my axis, what I'm going to label my axis with, so that's taking pi and dividing it by 4, right? So every major point is going to happen at pi over 4 units, okay? I'm going to have a shift down of 3 over 2 units, which means my midline is at negative 3 over 2. Okay. And I'm going to have a shift to the right, pi over 3 units. So we're going to take this one at a time, right? So we'll start with, I always start with the parent function, including the vertical and the stretches, and then shift horizontally at the end. Okay, so I am going to start with a temporary graph and then make our way to a permanent graph. So let's start by scaling our axis. Okay, so I'm going to make, since this is 3 over 2 and that's a half, I'm actually going to label every other box with a number. 3, 4, and -1, -2, -3, -4, and that should fit my entire graph. Now, what am I going to label my x-axis with? Well, since pi over 4 is where all the major things are going to occur, and I need to make sure I reach all the way to 2 pi, I'm actually going to make each box equal to pi over 4, making this pi over 2, and I actually can skip some things, and I get every fourth is going to be pi, 1, 2, 3, and then 2 pi. Okay, you could label each one if you'd like to. Just know that a major change is going to happen at each one of these lines. Okay, so now I'm going to start at my midline, which is at minus 3 over 2, right? And I'm going to label where my maximum value is, which is going to be 3 units above this. So 1, 2, 3 is going right there at 1.5, and 3 units below this, 1, 2, 3 at negative 4.5. Okay, so that's where my max will be, and this will be where my min will be. Okay, so let's graph the approximate 3 sine of 2x minus 3 over 2. Okay, so it is a sine graph, so we're going to start at my midline. Then, because it is a positive 3, we move up to our maximum. Back down to my midline, down to my minimum, back up to my midline. That's one full cycle, right? And we continue because we need to go all the way to 2 pi. So I continue maximum, midline, minimum. Midline. Okay. So let's connect these with a dashed line. That's this graph approximately. Okay. So this graph has all the features except the horizontal shift. That's what I'm going to do next, okay? I'm going to shift. Now, because I'm moving to the right, I'm actually going to continue the graph to the left so that I can shift it as well. So that means this will be coming from down here, and this will be coming from the midline. Okay, so now how much are we shifting? We are shifting pi over 3 units. Now, unfortunately, pi over 3 units is not going to fit nicely on this axis, right? There's no line that represents pi over 3. So we're going to have to estimate. Pi divided by 3 is approximately 1.04. Okay, now assuming that each box is equal to pi over 4, which is approximately 0.78, we need to go one box and a little bit on our shift. So I'm going to do that. I'm going to take every point and shift it one box and a little bit. One box and a little bit, one box and a little bit, and I continue. And I connect those values. So start from here to here, there to there, there to there, and I continue. Now remember, that's the minimum is a little bit, so we do have a little curve there. And I'll start erasing everything that I don't need. Okay, so we're stopping at 2 pi, so that means anything past 2 pi I don't need. Okay, I don't need these invisible maximums or midlines anymore. And I don't need the parent function that I graphed from. So I should have the label. Okay, but everything else can go. We can get rid of that. We can get rid of this. And that is this graph. Okay.